All right. So we've got a couple issues with this. We accept that we need to get off fossil fuels, and so one way of doing this, the third proposing, is moving towards a hydrogen economy. However, we have an issue with using hydrogen itself. The problem is we can create a lot of energy. Usually we're trying to go to electricity. But there's a problem in how do we store it. Like if you make energy out of solar cells, that's great if you're using it right at that moment, like on your calculator. But if you need to store it, so say you need to use it at night, where are you going to put that energy? That's what hydrogen is. Hydrogen is kind of it's an energy storage device. It's kind of like a battery. It works a little differently. But we have a couple problems. One thing that they brought up was the energy density of liquid hydrogen. And actually what they quoted you was the specific energy. There's two different values that you can hear about. One's energy density, which would be energy per unit volume. Another one's specific energy, which is energy per unit mass. So they told you the difference that liquid hydrogen has a very high energy density. So per kilogram of hydrogen has a lot more energy than per kilogram of gasoline. However, that energy density, which is per volume, it's totally flipped the other way. Liquid hydrogen, which is the most condensed form of hydrogen fuel, has less than a fourth of the energy density of gasoline. So that means that if say we're just going to burn hydrogen using the combustion engine, you'd have to have a tank that's 4 times the size of whatever gasoline comparative that you have. So if you have it's 11 gallons, now you need one that can contain up to 40, maybe 50 gallons of hydrogen. So there's a huge space issue right now, even if we condense hydrogen down to liquid state. And even that has a problem in itself. Hydrogen has a huge storage problem. To get hydrogen down to a liquid state, you have to you basically have to cool it a lot. In fact, 20 Kelvin is a temperature that you have to get it down to. Now the problem is, how do we keep it there, right? Because if it comes out of that state, we're increasing pressure in whatever tank that you have. Increased pressure inside a tank of fuel is how you cause explosions. So you have to have energy input. It's kind of like when you make ice, and you can put it in the best cooler that you can think of. After a while, it melts. Even if you have a lot of ice, you can say, well, after 2 hours, I still have ice in there, but half of it's water. So the same thing is happening with this hydrogen, right? So even though the hydrogen, we can get it down to liquid state, eventually it's going to evaporate out, and we got to do something about that. And right now, the way that they do that is they have what's called blow-off valve, which releases pressure inside the tank. The problem with that is you're losing fuel constantly. It's about 1% a day is what the average is. Second, they said, or thirdly, they said that hydrogen is the most abundant source on the planet, which is true, except that it's you never get hydrogen in the gas state, which is what you need it to, where you need it to be to use it as fuel. It's in water, it's in all kinds of things. So when we consider about going to a hydrogen economy, we also have to think about how much energy we have to use to get the hydrogen out. And main process would be hydraulic or electrolysis, which is where you use electricity to separate the hydrogen and the oxygen from water. They use that on nuclear subs and on some space missions. They use that technology. But it uses up a lot of energy. The efficiency usually ranges between 40 and 50%, which is all right if you have an unlimited fuel source. So if we could create electricity from solar cells alone, well, I don't care how long we got to sit in the sun to make electricity to do this, because it's all free. But we're not there yet. Most of our electricity, in fact, 45 to 50% is produced from burning coal. So the advantage that they tried to bring up about it solving some global warming issues, we still have to make electricity to make hydrogen. And right now, the process of making electricity is still putting CO2 emissions into the air. So that doesn't help either. Finally, there's an inherency claim. It's kind of subliminal, but if we want to use hydrogen for vehicles, you got to make the vehicles smaller to make the fuel cell viable. If we're going to make the problem with making vehicles smaller is that people who buy vehicles have to be okay with having a small vehicle. I don't see a ton of smart cars out on the road. They are increasing in number, but they're tiny, and people don't like driving them. Sometimes it's because I have more than myself to drive in this car. Sometimes it's I feel like I'm going to die in this vehicle because it's so tiny. And I mean, how many people know somebody that have a lift truck, but they don't tow a boat all the time, they're not towing motorhomes? This is kind of the American way. So you got to convince the public that smaller vehicles are the right way to go. And if you do that, and then that ties into the solvency claim. If you can convince people to get smaller vehicles, that also solves part of the problem about the efficiency of gasoline. Gasoline-powered cars right now, most of the energy goes to just moving the vehicle. And they're going to talk about there's probably losses, thermal losses in the combustion, so you're not getting great transfer from from gasoline to mechanical energy. But even the energy that you do get, most of it goes to the car. If your standard car is about 2 tons, so 4,000 pounds. If you're carrying 4 passengers, we'll make them average at 200 pounds a passenger. So you're looking at 4,800 pounds total, 4,000 pounds of that is the car. That means that only 16% of the energy that gets converted to mechanical energy actually moves the passengers. So if you can make the car smaller, then more of that ratio of how much energy moves the passengers increases, which increases the fuel economy, which would also reduce our dependence on